So here we will prove another basic property of gradient, that is gradient of phi divided by psi is equal to psi gradient of phi minus phi gradient of psi divided by psi square, and psi is not equal to 0. As I have told you, gradient can be written in terms of del operator. So gradient of a scalar function, that is here phi and psi are scalar function, differentiable scalar functions. So gradient of phi divided by psi means del of phi divided by psi. So we have to prove this basic property. So gradient of phi by psi can be written as gradient of phi psi inverse, and that is equal to the del operator or gradient can be represented in, I have told you, in terms of del operator, and del operator is nothing but this, that is I cap partial derivative with respect to x, j cap partial derivative with respect to y, k cap partial derivative with respect to z. So this is the del operator and this is the product function. Now the division function I have converted into product function, and these are two scalar function. One is phi, another one is your psi inverse. So if you take the partial derivative, then you will get I cap partial derivative of phi psi inverse with respect to x, then j cap partial derivative of phi psi inverse with respect to y, then k cap partial derivative of phi psi inverse with respect to z. And now you can use the product rule, that is product derivative of two product function, first function derivative of the second, then second function derivative of the first. So here if you apply the product rule, then I cap, then the function psi inverse into derivative of the phi, either you take the derivative this one first or this one first, no problem. So here it is taken psi inverse, this is second function, then derivative of first, that is derivative of phi with respect to x plus first function, that is phi, then derivative of the second, that means derivative of psi inverse. Similarly, you find out the partial derivative of this product function here also. Okay, this is for this function and this is for this function. Then you find out the partial derivative of, then for this second function, the first function psi inverse partial derivative of phi with respect to x as it is, and for this function when you take the partial derivative of psi inverse with respect to x, then this will be equal to minus 1 psi to the power minus 2, then partial derivative of psi with respect to x. Similarly, for this term you write here for y term, and for z term you write here, and the first term as it is. Now you rearrange the terms. This will be equal to psi inverse equal to 1 by psi partial derivative of phi with respect to x minus phi psi to the power minus 2. So this will be equal to divided by psi square partial derivative of psi with respect to x. So you also write for y term here like this, and for the z term you write like this. Then in the next step you see what you will do, you write 1 by psi del phi by del x plus j cap, this term, that means you take the phi term here and psi term here. Okay, so if you take the phi term here, this will be equal to I cap del phi 1 by psi del phi by del x, then plus j cap 1 by psi del phi by del y, then plus k cap 1 by psi del phi by del z. So you take the phi terms here, then minus, if you take the psi terms, this will be minus I cap phi divided by psi square del psi by del x, this term. Then for this term minus j cap del psi by del y, phi divided by psi square del psi by del y, and for this term k cap phi divided by psi square del psi by del z. So you take the phi this side and psi this side. Now you rearrange the terms. You take 1 by psi common. If you take 1 by psi common, this will be I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. Similarly, if you take here phi by psi square common, in the bracket you have I cap del psi by del x plus j cap del psi by del y plus k cap del psi by del z. Now you see that will be equal to 1 by psi and I cap del phi by del x plus j cap del phi by del y plus k cap del phi by del z. This is nothing but gradient of phi. Similarly, this will be gradient of psi, and if you rearrange the terms, or if you take the subtraction, then in the LCM you have psi square, then psi gradient of phi minus phi gradient of psi. So in this way you can prove the property that if phi and psi are two scalar function, differentiable scalar functions, then gradient of phi divided by psi will be equal to psi gradient of phi minus phi gradient of psi divided by psi square.